Welcome, one and all, to the 7th edition of our marvelous special problems. Today, we're doing a problem about compact discs. Yay! I know most of you may not even know what those are anymore. Little round, shiny things. Anyway, people used to buy these for their music before they had MP3s. But you might be familiar with DVDs or Blu-rays, so basically same kind of thing here. All right. So, manufacturer of compact discs wants to make sure the discs fit in their cases that they've purchased for packaging. Turns out CDs are circular, as I already mentioned, and the CDs and the cases vary normally, so we have the information here. So X is the diameter of a randomly selected CD. So let's start with that. So CDs. We're going to call that X, and normally distributed. Mean is 4, standard deviation 0.1 inches. Okay, cases. Said to call Y, also normally distributed, mean of 4.2, and same standard deviation, 0.1 inches. Okay, so that was given to us. Now, notice the cases are on average larger than the CDs, which is a good thing, right? We want the CDs to fit in the cases. I've had students in the past look at this problem and say, oh, cases are bigger than CDs. They always fit, but realize there's variability here, right? Not every case is exactly 4.2. Some are bigger, some are smaller. Not every CD is exactly 4. Some are bigger, some are smaller. So we're going to be investigating the random variable X minus Y. Okay? So X minus Y would be the CD minus the case. So it'd be a good thing if the CD minus the case is negative, right? Anytime it goes positive, the CD is not going to fit. So step one, we're going to want to know, well, what's the mean? Okay, so the mean of X minus Y will be equal to the mean of X minus the mean of Y. So 4 minus 4.2, that is going to be negative 0.2 inches. Okay, we're also going to be interested, obviously, in the spread. So the standard deviation of X minus Y. Remember, we can't combine standard deviations. We have to combine variances. And also remember, this is the counterintuitive example. Even though I'm subtracting two random variables, I still add their variances because variance is a measure of error. So every time I add error, whether I add or subtract, I'm actually adding error. I'm adding a potential for variability. So I'm going to have to take the square root of the sum of their variances. Okay. And again, this is the formula that works for independent random variables. We should have independence here. It says they're purchasing the packaging and they're making the CDs. So these are two independent processes. Okay, so let's see. We've got 0.1 squared plus 0.1 squared. So working that out, it's going to give me the square root of 0.02. Okay, so there we go. X minus Y. It says I got to describe shape, center, spread. Well, shape is normal. How did I know it's normal? Well, whenever I combine two normal distributions, the result will also be normal. That was in our textbook. Hopefully you've been reading it. And the mean is negative 0.2, and there's my standard deviation. There you go. Center, shape, spread. Don't need to even write words. It's all right there. All right, then the follow-up. What's the significance of this random variable? Well, as I already mentioned, as long as my value here, x minus y, as long as that's negative, the CD is going to fit. Once it goes positive, the CD will be larger than the case and it will not fit. So let's write that down. When x minus y is less than or equal to 0, the CD fits in the case. When x minus y is greater than 0, the CD is larger than the case. And that's a pretty big deal to the manufacturer, right? Obviously, they got to get those CDs in the cases or they can't package and sell them. Okay. Part B, compute the probability that a randomly selected CD will fit inside a randomly selected case. Well, we just basically did all the work here in A. So we want to find the probability that x minus y is less than or equal to 0. Okay, well, it's normal, so let's get a z-score. Okay, so there's our z-score calculation. And that's just basically 0.2 divided by the square root of 0.02. So 2. So there's our z-score, approximately 1.41 standard deviations. Okay. Now, again, I'm not going to use table A. I'm going to use my calculator. So I can do the normal CDF. Remember, that's under the distribution menu, which is above variables. Okay. So my lower bound, 0. Upper bound, infinity. My mean was negative 0.2, and my standard deviation was square root of 0.02. Oh, I'm sorry, it was less than or equal to. I actually have the complement there, don't I? There we go. So 0.92, blah, blah, blah. Okay, so there's the probability that a randomly selected CD will fit in a randomly selected case, about 92% of the time. All right, part C. The production process actually runs in batches of 100 CDs. If each of these 100 CDs is randomly paired with a randomly chosen plastic case, find the probability all of them actually fit. Okay, so they'd like to obviously do a production run without any hiccups. Just a nice clean run, no issues. Well, this is a chapter 6 question now, right? Here's my chances of success, and I want to go 100 for a 100. 100 in a row. So it's simply that answer raised to the 100th power. Now, I'm not going to say 0.92. I'm going to use what I have here in my calculator with all the decimals, because if you round this off and multiply it by itself 100 times, right, that round off error gets magnified and you can end up pretty far off the mark. So take that answer to the 100th power, and there we go. So I guess I'll write this with a little bit more decimal places. So we get, and again, some of you are a little unfamiliar with your calculator. That's scientific notation. So it's 2.77 times 10 to the negative 4. So in other words, a pretty low probability that they all fit, right? Working that out, right? That's 0.000277. Pretty low chances. Okay, and I guess I should write a sentence here. The probability all 100 fit is approximately 0.00277. Pretty slow chance. I guess on my previous problem I should have said the probability that a randomly chosen CD fits because these are practice problems for the AP exam, and they would expect you to answer in a complete sentence. Okay. Next question. Manufacturers are concerned too many of their CDs are not fitting. Yeah, because look, in a production run, there's a pretty small chance that we don't have an issue of at least one CD not fitting, right? Let's see, design a simulation using table B. That's kind of a bummer. I like to use my calculator for these, but we'll have to follow directions to determine how many CDs in a typical project. Okay. The reason they're going to say table B is because obviously if this is on the AP exam, you can't do the random integer on your calculator because they can't grade you. So that's why we'd have to use a table. Describe your simulation and carry it out. And then what advice would you give? Okay, so here we go. Now, here's the thing about your simulation. Our probability is, of course, not a clean, easy to work with number. So you're going to have to round it off at some point. And since I'm using the table, I'm going to round it to two digits. That seems reasonable to me. Okay, so remember the steps for a simulation, right? I will simulate. So you describe what you're doing. Fitting 100 CDs into cases. All right, assume a 92% chance of each CD fitting. Okay. Now assign our digits. So let's see, I'll assign 00 through 91 as a fit, and 92 to 99 does not fit. Okay, now it says to use table B. Somewhere I have a table B. Got one right here. I'm just going to start at the top, so I'll start at line 102. This is one of those tables that when I copied, somehow line 101 disappeared. So we'll start with line 102. So look at 100, two-digit numbers. Starting at line, well, let's not start right at the beginning. I'm going to start line 104. Why not? And count how many CDs do not fit. All right, here we go. Start at line 104. And again, it's 92 and above that don't fit. So fit. Actually, let's see how far I have to go. So let's see, 5, 10, 20, 30. So we have 40 digits in each line. So each line represents 20. So I need to do 5 lines. So I got to do 104, 105, 106, 107, 108. All right. So fit, 88 fit, 89 fit, 93. Okay, so here's my first that didn't fit. 07, 46, 02, 27, 40, 18, 50, 40. Okay, so just one in that line. Oh, 95, that one doesn't fit. '97. '95. Ooh, 91, right? On the cusp. It made it, though. 93. All right. 97. 95 again. 95 again, popular number. '94, 93, and last row, 94. '96. And there we go. So how many did I circle there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 that did not fit. Okay, so 12 out of 100 did not fit. That's pretty lousy, folks, right? If you're running a company and you're trying to manufacture something and 12 out of 100 don't go smoothly, you are not being very productive with your time. This is going to be quite costly. Of course, that's only one trial. I'm sure if you pick different lines on the table, obviously we're going to get different values. But we know that with a 92% chance of fitting, if you do 100 CDs, on average, you're going to find 8 don't fit. So that's too many. That's not going to work. So what advice would we give the CD manufacturer? It's actually pretty simple. Here's where I get a lot of answers. Again, going back, we mentioned this before, but there's always students that didn't hear what we said about changing standard deviations way back when. Changing standard deviations, probably not on the table, right? We'd have to come up with all new manufacturing tools, processes in order to get more accurate results out of our CD manufacturing. Notice we are buying the cases. We could inquire if the seller of the cases, if somehow they could make their cases more accurately, but again, probably not likely, right? If they could make them more accurately, why aren't they already doing it? So standard deviation, probably not on the table to change. But what we can change would be the sizes, the means. So should be pretty easy to say, hey, I'd like to buy larger cases, right? Or we might be able to make our CDs a little bit smaller. However, we got to be careful, right? Because there's probably specs that we need to stay with when we actually make the CDs so that they fit in the CD players, etc. So the simple solution, buy bigger cases. So I suggest the company buys larger cases. Okay. How large? Well, that depends, right? They really should look into all the other factors about how much money would it cost to buy however much larger case size, and of course, how many CDs they can tolerate not fitting in each run. So if they said, oh, we want to average this many not fitting in a run, well, then we could calculate for the optimal size case or larger, right? So we really shouldn't get too into the exact size they should specify, but we should tell them, hey, look into buying bigger cases. That seems to be the most simple, straightforward solution to this problem. All right, hopefully you've done this before the test, and hopefully it makes sense. So good luck on your test, and thanks for watching.